Thank you very much again, Priyanka, for the introduction. Nice introduction. I'm happy here to be talking on this subject called Scaling Industry with Edge. I would like to today share what I have learned during my work experience with you all, and hope it is useful to you. So the topic is Scaling Industry with Edge, more specifically the manufacturing industry. So here's what I plan to cover today in the agenda. So I would provide a brief introduction to what edge computing is, why is it needed. I understand there are a lot of people with a lot of experience, so I'll not dwell too much into that. What I would be more concentrating here is what is industrial edge. So when we say industrial edge, the manufacturing industry. So what are the use cases, or what what would enable the industry, the manufacturing industry, to scale with edge technology. And then I would also like to talk about what Siemens industrial edge is, what Siemens has to offer in this space to solve the problem. And then in the end, I'll also talk about certain off-the-shelf edge applications which are existing today, which the customers can straight away use it. So jumping in, what is edge? So I would like to go a little back in history, where we first, this is around 1970s, right, where the computers first started. We had those huge computers of a size of a room, is when we started. Nevertheless, they were the first computers, very important. And then came in the mainframes. This was in I'd say around 80s. It was clearly driven by the hardware. So the changes that happened over what was there in 70s was by the hardware, because of the huge size. To make it more affordable or usable, it was important to reduce the size. That's when the mainframes came in, and IBM had a main task in bringing these mainframes in. And then came in something called the client server. This started when the operating system called Unix also started, right? Where, if you guys remember, there were these terminals where you can ping the server, and there was what this showed was there is a possibility of communication between a client and a server. So the communication also started, and this also opened up the window for software. So we could see that software also has plays a main role in this computing environment. And then naturally, we're around 90s, or maybe late 80s, 90s, the great internet came in. This actually changed the era of how we interact with each other, talk to each other. Also, because of the World Wide Web, it created a huge network of computers, which made it possible to collaborate, share the data, communicate, talk to each other, and so on. We all know about it. So this is what changed a lot in how computers evolved. So this era was really important. And then came in something called cloud, the cloud computing, right? Maybe in 90s, maybe in 2000, when things were more centralized. So the big players like AWS, Microsoft, or Google, and many more companies, they came in and did some. So they set up a huge data center, and they showed us that we don't need to have everything running with us. Instead, we can upload it in the cloud, and the cloud does all the processing for us. It crunches the data, it does the computing, the virtualization came in, and so on. So what that did was, if you see, it made us to hold very thin clients, and all the big things used to happen centrally on the cloud. So if you also look at the way the evolution happened, right? Initially, we had our own computers. They were big and whatever, but I had my data locally. I used to do my processing locally. And then slowly we realized that, it could be possible to do all the hard crunching on a cloud, and I can have thinner clients. With this, what also people realized, maybe not everything needs to be on the centralized cloud. Okay, there are a lot of use cases for the industry, which says that maybe it is also important to do certain crunching locally, and that's when came something called edge, as we all know. Today, the edge computing. Some examples I would like to give is also like how I'm talking today. I'm sitting at home. This is an edge for the entire network that we are all in today. And then my voice, my video, everything is processed locally, and then it's sent out to a cloud. and then you all sitting on your edges are able to receive it, right? This is a typical use case of an edge, the importance of edge. So what also needs to be understood here is edge is not just about the end, I mean the edge, right, where I'm talking. It's also about connecting to the cloud, certain things happening on the cloud, and then getting distributed further. So that's what edge is. Another example I would like to give is about the autonomous cars, right, vehicles. You see, today it's a lot of experiments are happening where a car can drive on its own. So you can clearly see the concept of an edge there. All the decisions, really important decisions, are made in the edge where the car is moving. The surroundings, it shouldn't hit anything, maybe when to turn. And then there is also a cloud part which is trying to control this whole thing. So that's another example of edge. Now, what we see here is what is happening. The computing that is done at or near the source of data becomes important. It's not just everything goes very central. This is a little more decentralized. So that's the philosophy of what edge is. So what it does also, you see, is the centralized cloud. Now that's getting closer to me. So we are connected together, and I can do certain processing locally as well. So that's roughly what edge is. And why do we need this edge? So here are certain terms I would like to throw in. Maybe they are like attributes of the whole edge world. First thing would be the geography, right? Geography, not as in the maps, but the distribution. The whole world, is distributed widely, and there are long distances between us. And what we see is this geographic distribution also ensures that there are a lot of people accessing their computing power locally in their own places. So there it becomes important, like what we do know from our AWS, something called region, right? There are regions which becomes important to be managed so that it caters to people around them. And there is also very important part in the content delivery networks, right? CDN. What we know is they have their edge as well. So they would like to have their contents replicated on the edge so that it can be reached faster. So that's one part of one attribute of edge. And then second one, I would say, is speed, right? Latency. So I want to ensure that any communication that I do happens really fast. The latency, so the communication, the time that I spend between what I do and where it needs to reach needs to be as less as possible. Very clearly shown in the computer games that we play, right? The multiplayer computer games. So if let's say I'm shooting somebody in a game, and then I'm playing with a player who's sitting far away in a different part of the world, and then what he or she needs to receive as well is that the fact that I've shot and somebody's going to die. I mean, a computer character, and this obviously is going to have a lot of latency because the person is playing on the other side of the world. So what happens today is there are smart way of doing animations to cover up this latency. So if you see, that's something happens on the edge. So that's another attribute. And third, very important attribute I would like to introduce is something called human nature, right? So today, if I'm doing any operation on my computer or my smartphone, I expect results immediately. The moment there is, let's say, about 5 or 6 seconds delay, I become a little impatient. Something is happening. Probably it's not working or whatever it is. So that also shows that a lot of processing in terms of maybe UX, where I give a feedback saying, don't worry, it's happening. So things like that. Voice assistant, for example, we have at home, I can speak to Alexa, say, what's the temperature today? I expect immediate results. Otherwise, I think maybe this guy is not functioning. So these are some of the attributes which takes us towards what is needed in edge. And moving on a little bit towards the huge organizations, right? The big money people. So for them, from their perspective, why do we need edge? And one of the most important thing is cost, which is driven by connectivity and communication. So when I say connectivity and communication, if I need to be connected to the whole world in whatever ways we need, I need to pay for it, right? The connectivity itself, I need to pay for it. So it's cost for me. And when I send data through these networks, the bandwidth, also I need to pay. Individually, when I use this connectivity and communication may not feel so expensive, but the huge manufacturing industries or the energy industries, when they start using it over a period of time, the cost can be really high. I mean, even we can look at our electricity bill, right? Some days, some few months, if it's too high, we get a little worried. So you can imagine what the huge factories needs to face. So that's important aspect. And the last point that I've covered, but I think the most important one is the data security or data privacy. There are still a lot of industry out there who don't want to, share the data. They have their own IP, and the IP is protected by the data that gets generated out of these factories. So they want to ensure that the data remains within their factory. So the data security and data privacy plays another very important role in what we drive in terms of edge. So that was roughly what a short introduction to edge. Now we'll move on to the manufacturing industry. Okay, what I intend to cover after this is how this edge is actually scaling the manufacturing industry and its operations. Now, this is a typical manufacturing plant. It's a cartoon, but it gives a nice picture of what all happens in a factory, manufacturing factory. So I would like to speak or talk about few of the stakeholders. You look at here, there's a person sitting on a console and doing some operations. So he's probably the plant operator. So his job is to ensure that the whole plant operates in an ideal manner, efficiently, and in an optimized manner, right? So that's the responsibility of the plant operator. Similarly, there is also a machine operator. If you see, this person is doing something with the robot, and he also has a tab in his hand. So his job is to ensure that the machine that he's working on does its job well and in an optimized manner. So that's his scope. Similarly, there is logistic guys, if you see standing in here. There are also certain people wearing white dresses. Probably they are service technicians, right? They're talking to the manufacturing guys, the engineers there, saying what needs to be done to maintain the quality of the machines. So they are the service engineers and so on. So you can see a lot of stakeholders here within a manufacturing plant. And overall, their job is to ensure that the factory operates in an ideal manner, right? So how does that affect us, right? In the edge context. So today we know we have come quite a long way from when the manufacturing industry or industry 1.0 started, maybe early 70s, and now we are in industry 4.0, where we already know the factories, the machines, they operate really well. We get a lot of produce from there, everything, right, from our smartphones, cars, or food, everything comes from there. Now, how can we make these machines even better? So that's always the goal for every organization, right? So let's look at a few of the stakeholders. Yes, let's look at a design engineer. So so when I say design engineer, these are the OEMs, the people who are developing or creating these machines, which get deployed inside the factory. So this person's job is always to ensure that the machine that is deployed in production today gets improved. Every time he works on it, he needs to improve it. And there were times when these machines are developed and then deployed in the factories. And then there's no communication between what is happening on the factory, how is the machine doing, and then I, as a design engineer. The possibility is when I or my service guy goes and caters to what is happening with the machine, or somebody calls up and says, this is what happening is with the machine. But today, with edge coming in, what makes it possible is that there is whatever data gets generated on the machine, the performance insights into what is happening inside the machine can be monitored. So this can be generated in the edge, and the data, when utilized properly, there is a lot of improvement that the design engineer can bring in. Similarly, look at a service technician, right? Again, gone are those days where, let's say, every 6 months, once I'll go and service it. With the arrival of edge, what we can clearly see is the service technician can monitor what is happening with the machines. These machines they have different environments, right? They are operated in different manners by different factories. So certain factories, they run, let's say, 8 hours a day, certain factories 4 hours, certain factories at certain times, maybe when the output needs to be rigged up, 12 hours maybe. So now it clearly depends on how it is being utilized, and accordingly the service technician needs to go and service it. So how can this person find out what is happening with the machine? Clearly, if the data can be get generated and stored, and the service technician has access to it, the person knows when dynamically it needs to be serviced. And similarly, look at a plant operator. Overall, if the plant operator knows what is happening in terms of the production. There are small improvements always possible in different parts of the plant. And this data, if it again gets generated and is given to the plant operator, can be improved. If you see, all of this happens on the edge, and it's important to have processing happening on the edge. Similarly, the maintenance operator, if the maintenance operator gets to interact with the machine, when we say one level up, it's an abstraction over how the person is actually looking at the machine and how the machine, the person is able to operate on the data that gets generated on the machine. So the challenge now here is to all the time make the world's best machine even better. So that's the goal, right? For all of us in any work that we do. And this you clearly see, Edge is getting us there. Now let's look at so what does this give us when we do all of this, right? So industry IoT, we know IoT is rapidly growing. It's a market which there's no bound on how fast it is growing, and these IoT devices or the sensors and the things that can get deployed, the really small machines, are completely changing the way we interact with a factory. So how can and this goes a long way in enhancing the edge profile as well. Okay, so what I've shown here is three main ways this edge can add value to the manufacturing industries. To start with, the machine value add for your customers. This is again towards the OEMs who create the machines, who develop or manufacture the machines itself. What they could do is, by having a lot of data in the environment where it is being operated. We also have our software, right? We test it really well. We ensure that zero defect if possible before we release it to production. But we clearly know once it goes to the production, we still get a lot of defects or it behaves in a different manner. So the environment where its function is completely different to how an OEM would test the machine within their environment. And this environment, the data, when it gets generated from there, and if it is being made access to the design engineer, as we see, the OEE analytics. OEE is overall equipment effectiveness, right? So how can I make the equipment effective overall, not just in how it is performing, but how long it can last, how can it be improved, and so on. So this analytics, when applied on the data that gets generated, there is a lot of value add that the OEMs can provide. Another interesting part is they can also think of providing new business models, right? Like how we use cloud. So what they can think of doing is, I'll give you a machine. You don't need to pay an upfront cost. CapEx is reduced. I will charge you as and when we use the machine. So that way it gives a lot of flexibility. That's a new business model, really interesting one. And again, how is it possible? Only if I know when it is being operated and how much it is being operated. Again, that data needs to come from the edge. Now let's also look at how the R&D of the machine manufacturers, right, the OEMs, how can they benefit out of it? So they can get, talk about new improved market offering. So usage of data to get rid of non-utilized machines. So this is like, I today ship a software which has, let's say, 10 features. If I don't have any other feedback mechanism of how it is being used, next day, again, I'll give probably with another 2 features to what exists today. But then if I know that these are the 3 or 4 features which are mainly used, or let's say 90% of usage, the rest of them is maybe 5 or 10%. It's very clear that for me, when it comes back to me, I need to concentrate on those 3 or 4 features. Similarly, the machines, the way it is being used, if the data goes back to the R&D, they know that these are the parts or the features that they need to concentrate on. So that way they can improve the features and give a more effective machine for the manufacturing plants. Similarly, the machine optimization. See, it's very hard. The machines, like for example, the computer that I'm talking on, maybe it's a little compact and small, or the smartphone that I have. But then in manufacturing industries, those of you who have seen, the machines are really huge and complex. It's not easy for me to just analyze what is happening in there. So it's important that the small details of the data, like the temperature or humidity or the pressure that is being generated or the energy consumption, all of this data, when it gets generated, it gives us new ideas for the R&D management. very nice example which is quoted here is saying that, probably at this part of the machine I need to improve the air filter system, so that way, it gets cooled down and the machine life is getting lasted. So that's again a very important point. And the service industry, right? It's not just I sell the machine and I'm done. The service industry is huge, where the OEMs can send their service technicians and service a machine, and when that makes a lot of money, there are huge contracts that can be improved by seeing that, the way the machine is being utilized, by collecting the data. Probably more spare parts are needed for specific customers, and that I can sell. And the machine availability obviously gets improved, because now I know that, this machine is overutilized. Maybe I need to go and service it and, oil it or do whatever needed, and that would ensure that it lasts longer. Same thing to do with the service optimization as well. This is another interesting one where, I can probably give a new contract to the customer, which is my factory, saying that I will see, I know that this person is utilizing this machine in this manner for this long. So accordingly, I'll give you a service contract. It doesn't need to be a fixed one. So that way, both benefit, the guy who's giving the service and the guy who's accepting the service. So these are some of the benefits which Edge brings in. And then now let's look at it a little from a little higher abstraction. What's clear is the data that gets generated in the machine needs to come out, and then that has to be utilized. Now, let's look at something called extended machine functionality. You look at the picture on the left side. This is typically a factory. And today, most of us know there's something called a controller. You all, most of you might know that there is something called a PLC, Programmable Logic Controller, which is the controller inside a factory. And this controller is normally attached to IO modules. And these IO modules are the ones which are connected to the machines. And then the input comes in, and I can write certain programs within this PLC, which would then provide certain outputs. And that's why we control a factory today, right? Using a controller, which is PLC. And what are the benefits of this PLC? Why do we even today use PLCs, right? These PLCs are, one is they can work in a ruggedized environment, like there is heat, humidity, it still works well. Another important aspect is the real-time behavior it gives. And third, most important one is the consistency that it gives. I know customers who have bought PLCs in their factories. One of the beer manufacturers, for example, in Germany, they bought this PLC and installed it about 20 years back. And today, even now, if we go to them saying, we will give you something new and really interesting, they still hesitate because they're very happy with the way it functions. It's been 20 years, but the PLC which is installed is fantastic, and they're very happy not to touch it. So that important is how PLCs. However, this PLC also brings in a little difficulty in the way it is being programmed, right? So only certain specific languages, like the IECPL standard languages, can be used to program this PLC, like a ladder logic or yeah. So so this limits the way today. See, all the engineers who pass out from the colleges, right? They know what is object-oriented programming, C++, C#, AI, and so on. So the IT has improved vastly. But can I use them on a PLC? Maybe it's a little hard. That's where edge computing enhances this whole profile. Once I have an edge IPC, industrial PC running in the factory, I can run operating systems which are a little higher level, like maybe a Linux or an embedded Windows. Of course, there are challenges. It's being evaluated even today by a lot of organizations in terms of real-time performance. Up to an extent I can provide, but the consistency, when a lot of threads run, sometimes I get starved out, and then I don't get the time. But in a PLC, if I have a 10 millisecond cycle time, I know that after every 10 milliseconds, my program will again start, and those things would be run. That's very consistent. But in a high level program, maybe that's a little challenge. But then that's where evaluation is happening, and edge computing is making those innovations possible, wherein I can use my C++ or a SQL DB inside the factory in the edge. And this also brings in another important aspect. As we know today, AI and ML is making so many great things possible. So if I have an edge IPC running inside a factory, I can deploy my ML model inside this edge, and do wonders with it, right? I can make predictions, I can do predictive maintenance, I can get some important insights into what is happening. So all this is being possible when I can think of doing the processing on the edge in a right manner. We can also look at something called remote software management. What does remote software management mean? That today the machine builders, the OEMs, were sitting in their offices. Earlier times when I had to deploy whatever I had to deploy in the various factories, maybe in terms of the software which gets updated in the PLCs itself, I still need to go visit the factories and provide. But then with Edge coming in, where I have now connectivity, as we saw in the beginning, Edge is not just in silos, but it is when connected to a cloud. That's when the whole philosophy is completed, right? So once I get this deployment model available, I can update anything that I want within a factory in just a click of a button. I can deploy new softwares. I can also probably manage what needs to go where, different versions, and so on. So this is again being possible because of the Edge philosophy. And the last one also, I'll touch upon a little later, the IT integration, right? So we all know what IT is, information technology. We have done great things using that. This is being possible when the data from the edge, if you see on the right side, the Edge app collects data, sends it to the cloud, and then once it's available on the cloud, I can utilize all my powers in IT. So this is being made possible again if I have something running on Edge and pulling the data. These are some of the ways we're making progress using Edge. So I would like to summarize what we saw so far with respect to manufacturing plant. Edge computing introduces IT mechanisms that we spoke of to the shop floor to provide local data processing. So that's important, right? Even in a centralized manner, there was data available on cloud, but now there are use cases, as we saw, which is important to be processed locally within the edge. So this makes it so we are moving a little away from centralization to decentralized way. Again, as we saw, edge is not the silo, right? It's computer connected to the cloud as well. So there is a level of decentralization being introduced for things like acquisition, storage, analytics, and also transfer the data. So that's what we saw. Another part is the flexibility that comes in, right? By deploying, you see in this picture, so it shows that I can control what is happening on the factory sitting on the cloud, because I have my processing happening on the edge. I can install newer software. I can find out probably something is wrong here. This guy needs update, and so that's possible. And the third one reduces complexity and IT costs, right? So there are new ways of creating edge devices, putting it there, and then controlling that in an automated manner. So in our software industry, we have done a lot of automation, right? Even in manufacturing industry, there is a lot of automation happening, but by bringing in the edge, the automation goes one level up. So that's been possible. And the last one, secure data handling within production, right? So this is important, as we saw. So there are a lot of manufacturing customers who know they still are not completely exposed towards IT. The people, the people who are sitting in the factory and working, they would rather still want the data to remain within them and not expose it. But by providing edge and the technology and explaining that part, we also show that the data that is secure and you don't want to let it out, we could still retain within the factory, and the ones which can go out can still go out. So that's being made possible by edge. So I would like to to connect all of this, I would like to give one of the examples that I'm aware of, this FPS, which is Food and Pharma Systems from Italy. If you see the image on the left side, right? So they manufacture these huge machines. And why it is needed is in the pharma industry, it is important sometimes that the humans are not able to touch the ingredients with their hand. They are sterile, and they can do damage. So it's important that there are these gloves. You see the brown ones. Also, this guy is operating it. So the human operation is always done using these gloves. And it can be it can be operations like probably measuring what is happening inside, mixing something, and so on. But in this case, FPS Systems Italy, the use case was, there is also this HMI. If you see on top, what is HMI is a human machine interface, where you can operate with your fingers. You can enter some data or give a command and so on, but then you need to use your fingers. But in this case, what was happening was the operation, or a set of a process and a set of steps in that demanded that the person actually does certain operations inside the machine using the gloves, take your hands out and do certain HMI operation, again get in there and do. This doing once looks okay, but if you can imagine that a person like this needs to be doing it the whole day, and the operation can be really tedious, and it's a little irritating for the people who are using it. So it's not really, the UX is not good. So what could we do there? So the HMI operations which were being done with hands, how about introducing a voice-based processing happening, right? You see the examples that is given. Hey Sam, so, start cycle A probably, and then I do something with my hand, and the moment I am done with my hand, I can say close wall B, and then immediately do something else. So if you see, it's a very simple thing, but it's important when done over a period of time. It's important, the overall effectiveness becomes much better when you introduce something else. So that was a small example that I wanted to cover. So now we saw what is the possibility which exists. I mean, we of course saw part of it. There's a huge scope, but then we saw that there is a lot of potential in manufacturing industry to bring in the edge solutions and improve their overall output, or the business itself can be improved. So what do they do? Today there are multiple vendors offering this edge solutions, right? And we know that IoT and the technologies has ensured that anybody can do it. I can do a small startup and actually provide a solution to a customer. So how do they go about getting a solution done for themselves? So I've tried to show 4 things here. The top 2 are something called make. One possibility is that the manufacturing industries can make it themselves. They're some of them are really huge. Let's say BMW. They're huge. They have a lot of money. They can have their own software set of people. They can have their own data center and so on. So they would actually like to look at, maybe I can develop it myself, right? It will be proprietary. I can do everything on my own. Of course, do they want to do that as a question mark, because their main crux or core work is something else, not developing software. So one possibility what they can do is they can use open source products. Today, we know anything that you want to do, you just search for it, and then it's available in some form or the other. And then you do a little bit of tweaking, and then you can utilize it. So open source products can be utilized, and maybe they need to integrate it and extend it a little bit, and you can create a solution for you. However, we also know that the stability of this open source, some of them are really good, of course, but then not all might be really good. And how long is the support going to be available for me? So that becomes always a question mark, right? And the second one, the hyperscaler services. What I mean by hyperscaler services is the huge cloud providers that we have, the AWSs and the Azures and the Googles, right? They also have done a lot of work towards this edge market, IoT core, for example, right? You can deploy an IoT device, and then there is way using AWS IoT core where the data can get into the cloud. So that's possible, and then you can do your processing there. But you can also, imagine the challenge there. One big one is that, I as a manufacturer, I'm stuck to your cloud. I cannot do anything outside of that. So I need to stick to that. Would I want to do? Maybe, sometimes, maybe not, right? I would like to have my own flexibility. And I would still want to do something on the edge, some custom processing, right? Sometimes proprietary. So there again, I need to extend that. So that would be another challenge. Of course, possible, but it's a challenge. Now, that's the make thing, right? There are also buy options available. Let's start with the OT providers. OT, when I say, is operational technology, right? The domain, people who know the domain and what needs to be done there. So there are a lot of companies who operate in this space. For manufacturing industry, Siemens is of course one of them. There is Bosch, there is Cisco in the edge itself, and there are many more. Okay, all of them have their products here. And can I go to these people to get my offerings? Of course, we can. What these OT providers can do also is there are a lot of benefits, right? They understand the domain of the factory. They know what's to be done then, and there are decades of experience for these people. And what is possible is the OT providers can also internally collaborate with the hyperscalers. So that way, a customer who's a manufacturer, who's manufacturing industry, who's buying a solution from an OT provider, is abstracted out of what is happening behind. So that's a really good option. And another really good option is the IoT startups. today we know that there are so many startups doing really fantastic work. So there is a possibility that the startups also offer. The challenge there is, since it's a startup, the whole setup is smaller, they could only target on certain use cases, focus on them and bring really good quality. This is happening. But then for the manufacturing industry, they don't want to then take the headache of picking up solutions from various ones and then assembling, or probably hire someone else who can integrate these things. So that could be the challenge. So these are some of the make and buy options for the edge solutions with the manufacturing industry. And I would like to also introduce one really important aspect. I think some of you would have heard about it, called OT and IT integration. So what do I mean by OT and IT? So operational technology. Let's go a little bit details into what it means is. So let's say I'm a car manufacturing plant. So the engineers who work on the floor, they know what exactly to do, what to monitor, how fast it can come out, where it needs to be serviced, how is the automation happening within the plant, what is the automation code, what is the configuration, what is the engineering to be done. So what I mean is all the real domain parts of where I'm working is part of operation technology. And the requirement from manufacturing industry towards an edge solution, they would want to ensure that these things are dead right. So like robust and stable. They want to ensure that the solutions that they want to deploy in the factory is really robust and stable. Because if you look at the cost that these manufacturers or the manufacturing industry faces, right, where do they spend a lot of money? It's not in the salaries to the people who are sitting, to the CEOs of the plant and so on, that they spend is the highest. Okay, that's not the one. Is it to buy those machines? Also is not the case. Where it's a little inverse cost actually, where they really have to spend is if the factory comes down, for whatever reason. Let's say the machine conks up, or one of the processes goes down, or whatever happens, or the power supply goes down, whatever. When the factory stops, that's when nothing is happening. It's all shut. And that can have a spiral effect, in terms of delivery, what is happening, the new raw material coming in, where do I keep them, and so on. That's huge. So it's very important for them to ensure that they get robust and stable solution. And again, dependency on online services needs to be very little. Error-free, right? We looked at the cost. It's very important that the factory personnel are able to operate it on error-free. This fourth point, plug and play for existing and heterogeneous production is becomes again very important for them, because today, as we saw, there's decades of experience already gone into a factory, right? They've set up and they are operating in a very efficient manner. Do I want to go and fiddle around or make bigger changes there? I don't want to. I want to ensure that what I bring in terms of edge solutions can get plugged in within the factory and things remain the way it is as much as possible. So that is another important requirement if they want an edge solution coming in. Also, needless to say, long-term support, right? They're not there to just end in the next 5 years. They want to do it forever. So long-term support becomes another important aspect. Now, what we are also looking at is with the IT, the information technology advancement that we have done, right? We know it. We're all the day working on various softwares, right? DevOps, MLOps, AI, ML, AR, VR, and so on. So whatever advancements have happened, we have made our industry the software industry very efficient in terms of automating things and so on. Can we now integrate this into the operation technology, on the factory? Can we integrate this? Then you can imagine that all of this experience that we have learned on IT can be actually shifted to OT. And if it can be integrated, the overall efficiency that would improve would be really high. Typical things like can be integrated to existing IT systems. So even the big manufacturing industry have their own small data centers. Can we integrate this whole thing with their IT, probably the SAPs that they have, or whatever way they store the data? Can we integrate this so that things can be automated? That would be a requirement. Up-to-date IT security, as we saw, is really important. Expandable through open interfaces. That's an interesting part, that if I provide a solution within a factory, can I have it really open, such that let's say I from company A go and give you something, okay? can I run something from a company B, which I have good association with? I know I can, work out deal which can be cheaper from. Can I run those things here? If something like that can come up, we know, right? Open interfaces that we give, anybody can call it. Similarly, can I bring that into OT? That's very important. Do we use state-of-the-art technology, right? Also important. When somebody wants to buy something, they want the best. And of course, available worldwide. So these are some of the OT/IT requirements that the manufacturing industry would expect in an edge solution, right? So now that we have understood what exists, what are the requirements, what would be really important, I would briefly like to speak about what Siemens has to offer. Of course, there are a lot of competitors available. Now that I come from Siemens, I would like to explain what Siemens has to offer. Similar products, I'm sure, exist from a lot of competitors as well. So what is our philosophy here? Flexibility, right? I mean, we know Siemens has existed for a really long time, and there is a lot of experience. Siemens makes machines, Siemens makes software, and it's all deployed, and there's quite a bit of market share. So flexibility in terms of integrating perfectly into existing manufacturing plants is completely provided by the edge philosophy that we have. Focus on IT and OT. This is done in a big way. We will see in the next few slides how they are completely open for IT systems to get integrated, which gets into the OT great robust systems today that we have. Completeness. So when I say completeness, what it means is we looked at some of the cons of a startup, right? Not of a startup, but in utilizing what they provide. So these manufacturing industry, like we spoke about BMW, right? They are producing cars. So they don't want to get into an integration software job or developing some. That's not their core strength. They would rather concentrate on what their core strength is and buy something from outside. So while doing this, they want to ensure that when I buy a solution, it's end-to-end available, completely out of the box. I don't need to do anything. I'm ready to pay you a premium. So that completeness is available here. And then the quality, of course, in terms of there are certain applications that I provide on edge, the workflows that I get, the security that it offers, can it scale not just on inside an edge, but can it scale for a plant requirement? The quality that is provided is available. An open ecosystem. So when I say ecosystem, I mean, we know what an ecosystem, right? Is like the earth itself is an ecosystem. There is water, there is air, and there is land, and we coexist. And if something changes in one area, for example, let's say our lakes get reduced a little bit, we obviously see a lot of less greenery. The birds are less probably, and then people living around don't enjoy living there anymore as they used to when the lake was big. So it changes, right? So it's important that this ecosystem, the interaction that happens exists, and everybody is able to participate. So the Siemens edge philosophy is also on the same lines where it is completely open. Any competitor or the manufacturer itself, like they say BMW, they can develop their applications and plug it in very easily. So the third-party devices, and it's not just that, even the devices can be done. We'll see that a little later. So this is a little bit of internals of how the industrial edge from Siemens operates. So if you see here, the lowermost layer is the IPC, the industrial PC, or the automation hardware can be, of course, from anybody, but then hardware is needed. Industry grade hardware which can sit inside the plant, and then on top of it, it's something called an industrial edge runtime, which comes in. It can have a lot of features. What we offer is something called security. I mean, very important. We saw it ensures that the applications that run on top is completely secure from any kind of malware or attacks. User management. So another important aspect where we should clearly be able to control who can do what, and how many people can do it. Authentication, authorization is available. Application management in terms of I have so many edge devices, where which software goes in, which version needs to go where, which needs upgrades, and so on. So application management is available. Connectivity, very important one, the southbound one, right, where the edge itself is nothing if it's not connected to the factory machines that we saw. So all kinds of connectivity is available. And on top, what is possible is Siemens can have its own applications to partner. So I'm partnering, let's say, with a manufacturing industry, can develop their own applications and push it in, and then self-develop applications. So anybody like today we have our Android, right? So I can I can sit at home, develop an Android app and upload it in the Play Store, and anybody could use it. So that possibility is there as well. So this is being made possible here. And how does this whole industrial edge get deployed? Okay. So there are three layers again. So one on top is something called Industrial Edge Hub. Like we have the Play Store, right, or a Docker Hub. So that's public. Anybody can go and upload their applications. Of course, there are certain minimums, I wouldn't say standards, but certain tests expected out of for it to be robust, and the application needs to be reliable. So that needs to be met with, and then it can be uploaded. And then the second part comes something called industrial edge management. What it is it gets deployed within the factory. So this is within the factory data center where they have certain computers. So it gets deployed there, through which I can then orchestrate or have a look at in my entire edge ecosystem. So the last one is, of course, the edge runtime, which gets deployed on the edge IPC, so industrial PCs or an HMI or communication or a virtualized hardware. This is another interesting one, because we know today, right? I can ask for an EC2 instance, for example, on an Amazon whenever I want, and I get it. So the scale is huge. I can reduce my need or increase. So similar possibilities also exist today using virtualized infrastructure and any certified hardware. It doesn't need to be from any particular company. It can come in, and this whole ecosystem works. So there are applications locally available. So the particular plant can decide to pull which are the applications they want to run, or even if they develop, they can upload it there and pull it down. So it's available locally. They can decide when to deploy what in which hardware. So I would quickly go through some of the off-the-shelf applications that exist today, which clearly target the use cases that we saw right earlier. So you can see here, these are the southbound applications which exist, which help me connect my edge or the IPC to the various machines within the factory. So let's start here. So Semantic S7 is one of the connector which takes care of the semantic protocol. OPC UO, we know it's a standard protocol. Simotion, Synamics, and SLMP are other connectors which helps us connect to the various devices that operate on the factory. There are also some generic protocols being supported. So these are all, by the way, different applications. You can just download them and deploy them. Yeah. So Modbus, TCP connector, Profinet connector, Ethernet connector, MQTT, we all know, and OPC UA, we saw this. So, and apart from this, there also exists something called cloud connector. So if my factory data comes in, as we saw in Edge, certain data gets retained here, and some of the data needs to be pushed to the cloud, and that is possible via MQTT. For example, I use an MQTT connector here, and this can directly send data to AWS IoT core using the MQTT connector. So that's a possibility. So once the data comes in via this connector, it sits on something called Industrial Edge Databus, which is internally supports MQTTs. This is another application, and this can be configured using the services that exist. And on top of that is the most important ones. So these are the tools for me to connect to the industry. But once I connect to the factories, what can I do with it? So these are some fantastic applications. It's not just from one company, but there are also third-party applications possible, as we saw. So like Flow Creator, Performance Insight, and all this is available on the internet. You can have a look at it if you're interested. So these are available. I would like to go a little detail into a few of them. So one of the applications is Performance Insight. What does it do? It is targeted for the plant operator or a machine operator, right? So more of a plant operator, because what it helps us do is, you see the tabs here, so you can connect it to where, let's say, energy meters, motors, alarm. So you can connect to various parts of the plant, and then this application also provides widgets where you can decide how you want to look at it. Let's say I want to look at it, the data getting generated, time series data getting generated in a bar graph. You can decide to look at that. So this makes it very efficient for a guy sitting, the plant operator, sit and find out what is happening on the plant. He doesn't need to call up people or go and see. He gets what is actually happening because they're all connected, right? And what does this help is for the person to do quality improvement and something called OE, right? Overall equipment effectiveness, or in this case, the plant itself. So this is a really nice app. Energy Manager. So I mean, people want to have transparency into their whole factory, right? Where energy is spent more, where it is spent less. Probably this is the area where there's a lot of energy being spent, but then certain things are not operational before beyond night, let's say. So it gives the possibility where I can go and reduce my cost by understanding what is happening within the plant. Anomaly detection, very important one. So if I can connect some of my devices to this application, and collect the data, I can find out how is the flow happening, right? It's possible that, and so let's say there is a machine which is operating and it's slowly degenerating or, degrading. So it doesn't happen that, one fine day it stops, but you can see the signs, that it's going down probably. And now if you connect that here and, monitor the key parameter performance KPIs, right? And then you can find out that in a certain time period, there is an anomaly. So when that happens, you can clearly connect this application to, let's say, something like an alarm generator, which we see next, which will warn or notify the plant operator to see that, something is going wrong. Probably I need to call the technician or talk to the OEM that, something is going wrong. So this is being made possible by this application. And when you have this application, the operators also want to get little bit into the future as well, right? Some kind of prediction that, how long this runs before the oil dries out, for example. So even that support is provided here, where you can create some kind of model, existing models, where the person doesn't need to code, but then, out of the box, it's available. Notifier. So we saw a use case in the anomaly case, right? So there is an application which is running. I can also use this notifier and connect to various operators of the plant, where, if an anomaly gets generated, I can configure using this application that please send this message to this user 1, 2, and 3 on the mobile or the smartphone. And if the operator responds saying that, okay, I will look after this, then the message again goes back to the application, the notifier application. Everybody gets to know that, this is the person who's looking into the issue. So that makes the orchestration easier, the issue. Live twin, my favorite one, very important one. So if you guys have visited the plants, right, they're not always very easy to go around. Sometimes, it gets very hot there, very humid there. Sometimes it's very dusty there. So it's not always possible that, I can install sensors or, devices in all possible places. So what do we do then? So let's say I want to monitor temperature at a particular place in a machine. So that temperature is not independent, right? It is actually dependent on many other things, probably the power consumption that it has, or the pressure that is that part of the machine is taking, and so on. So theoretically, using the software, I can connect those important KPIs of that machine and then simulate a temperature in that part of the plant, where I don't need to, let's say, I'm not able to put in a temperature sensor. So what this helps us give is create your own live twin. So when I say digital twin, so this is a live twin because the data gets fed in there and it simulates and gives you the actual value. So that's another application available. Machine insight. So previously the performance insight was for a plant operator, and this is for a machine operator. So the key ingredients or the data that gets generated out of the machine, which we saw, can be monitored using this. And the last application, which is an ERP connector. So today the application is provided where, if let's say the plant has like an SAP. So how do I connect to that SAP and have the flow happening over the plant in a smooth manner? A requirement comes into SAP saying, please produce, let's say, 40 items of this version, and then that can get into the plant, and we can control that IO using this application. So yeah, that's roughly what I wanted to cover today, and I hope it was useful. Any questions or feedback?
Thank you so much for that presentation, Shelly. We definitely have a couple of questions coming in, as well as some requests for the copy of the slides that you shared. So just to everybody attending, if you could please drop us a note after the session at events@zinnov.com. We'd be happy to share the presentation that Shelly just took us through. So Shelly, what I'm going to do is, of course, I, as usual, have a couple of questions that I'd like to pick your brains about, but I'll prioritize audience questions and I'll try to integrate them into the set that I have as well, so we can take them one at a time. Does that sound okay?
Yeah, sure.
Okay. So I think, first and foremost, just to set the context, like we were discussing, the unprecedented pace of disruption, the technologies had, especially because of COVID, and the fact that edge computing is still fairly new as a concept in India. Would you say that there is a need for organizations and teams to unlearn certain specific or outdated ways of operating to be able to grasp edge computing most effectively? And could you touch upon some of those kind of mindsets or factors?
Yeah, sure. Sure, Priyanka. So, see, as we spoke earlier, edge is not a technology as such, right? I wouldn't call edge as a technology. It's more of a philosophy, right? It's a data or network philosophy, and this philosophy actually uses the existing technologies. So there is I wouldn't say people need to unlearn anything. It's more of a how do I organize or strategize what's coming in and realign to that. Also in architecture, architecture can be viewed in many ways. One of the ways that I look at it is it's a combination or a sum of forces. Forces, I mean the requirements, functional and non-functional. Then there is communication happening. Decisions need to be made, and the last one, which is called creativity. Okay, it's very important to be creative when you're making an architecture. Similarly, the edge philosophy works exactly in that area of where the philosophy is very important. So I wouldn't say people need to unlearn anything. All that they need to do is apply the right mindset, how you look at this. I would like to say, look at an example I can give probably. The car, right? If I'm traveling from a place A to B, okay, what I do is normally I get in and I open my smartphone or a map which is integrated. I just say, okay, I want to travel from here to there, and immediately we get a nice map and a way, and it also gives me the time that it takes. So now if we get into what are the technologies involved in, that's an edge solution, right? Where it operates on the edge. So if you get into what is available, one is there is an embedded system available on my smartphone maybe. So is that something new for edge? Definitely not, right? We've been decades of experience we have for embedded system. Now this data also I need to connect to the cloud to get probably the weather. Is it rainy or stormy? Or how's the traffic in the future? So I need to get this. If you see the technologies involved there also, it's something which we have been doing all the while. But then overall, if you see this use case, it is a edge use case. So I would say nothing needs to be unlearned, but look at it in a different manner.
Got it. So it's more about the perspective, the approach, the strategy and creativity aspects of leveraging existing technologies. Is that right?
Correct. I would say it's a philosophy, the edge itself.
Absolutely. So a couple of questions, just adding on to that, maybe the flip side, we spoke about a lot of the benefits and the best ways to leverage edge computing, but what would be some of the major key challenges to edge computing in India? If you could shed some light on those as well.
Sure. So I wouldn't say, so at least I'm not aware of challenges for edge computing in India, but I would maybe in India specifically, because, I feel we can do things which anybody can do. And I would then say, what are the challenges for edge computing itself? It definitely applies to India as well, and maybe to others as well. One is, if you see what is an edge, so there is something happening on the cloud, and then because of the existence of IoT, a lot of IoT devices, now I'm able to connect to a lot of places and do my overall processing, right? So what this does is there is a lot of increase in exploitable surface, right? Because now my software runs in one IoT sensor, probably an IPC device, and so on. So I know individually I will make it secure, but when it comes to edge computing, since the exploitable surface has increased, so it becomes a little more prone to attack or malware, right? So that makes it, we need to ensure that, that challenge is addressed. The security, very important thing. Another important thing I would say is, see, today, if I develop a client server based application, I deploy them and I have ways to test them effectively or efficiently, and also have automated systems doing this. Now, same thing if I want to do for an edge solution, I have one part of the software running on cloud and maybe something else on a device. And then this also connects to various IoT sensors, for example. Now, once I have them deployed, for me, it becomes very hard to actually monitor the whole thing. So probably when we get into this technology, it becomes a challenge for me to monitor what is happening around, so that it helps me in troubleshooting.
Right.
That's another one. Third one I would say is more of we shouldn't overdo the edge game itself, right? I shouldn't now bring down all the centralized processing to the decentralized way. So that balance needs to be right by understanding what the data is. Otherwise, my return on that investment is going to take time. So that I would say would be.
Thank you so much. I'm just going to quickly summarize to make sure I understood. First was security. Second was the continuous monitoring to be able to troubleshoot effectively is a little bit of a challenge. And lastly, you spoke about not overdoing the edge game. So essentially just finding the right balance in that sense when you're adopting it.
Right.
Fantastic. Okay, a couple of other questions from the audience. We have somebody asking that what would be the hardware spec of an edge node connected to a big data ecosystem?
Mm-hmm. So we touched a little bit upon this earlier. So what I'm trying to do there is, when I say my edge device and a cloud infrastructure, let's say the cloud infrastructure or can be in different abstractions, right? One is right on the cloud or probably within a data center where the big data gets accumulated. Now, when I look at it from the edge perspective, I need to ensure that not all of the data is something that I'm going to process on the edge. It's only the specific data that makes sense for that use case, which is important. So what I'm trying to get to is, now what I process on the edge is never big. We also saw things like speed, latency, and those aspects is very important when I'm doing on an edge, the human feel of immediate response. So if I have to do that for a big data, it's not going to happen, right? There is a lag and there is a time. So I would ensure that important parts that I do on edge still remains limited data, and what happens in the backend would still happen the way it happens today for the big data.
Got it. So then in that context is, another question around how to manage data loss while using edge computing. And I feel like right now when we're talking about backend versus front end data, it might be something to consider. So how would you effectively manage data loss?
Mm-hmm. So data loss is a key here, because see, edge itself, what it means is process the data at the node. Okay, so I would say that's where this OT and IT also comes in. So once the data gets generated in an OT environment, I need to ensure that the IT part of the software processes, right, they need to become active, and I need to ensure that what the data that comes in. See, there is also this edge computing, cloud computing, and there's something called fog computing. Okay, people would have heard about it. So this fog computing is it is in between edge and cloud, and I would say the data loss becomes key to this fog computing. So what does fog computing do? This guy is the one who decides what data goes to cloud and what remains here. Okay, that's where I would say maybe there is a possibility of data loss, or sometimes there is an intentional, maybe I don't need this. So I would say that needs to be handled there in the fog layer.
Absolutely. Got it. Thank you so much. And I think we did touch upon this, in the presentation. You definitely took us through this, but we do have a question on a couple of more examples. If you could brief us on using edge cloud in both IT and OT.
Pardon, edge cloud?
Using edge cloud in IT and OT.
Oh, yeah, sure.
Just a couple more.
So, yeah, sure. One example that comes to my mind right now is, we spoke about this PLC, right? PLC is the controller that controls the plant. So PLC gets connected to modules, which has, let's say, an IO module, we call it. There are a lot of machines. Or okay, let's look at it in a more simpler manner. So at my house, I have the water tank, right? So when the water gets filled, I need to ensure that the water doesn't get pumped up anymore. The motor needs to stop. So how do I control this? So I could probably have two sensors on the tank, one on top of the tank and one on the base of the tank. The moment the base of the tank sensor clicks, the motor should get on, right? And then the water gets filled up, and the top one clicks, it should say, okay, I'm done. It's full. So this is a typical controller logic, right? A very simple one controller I can do at home. Now this is again falls in the OT world. How would I bring in an IT here? So what I would have written is this program which will control this, that, if this guy is true, please switch on the motor, and if this guy is false, then things. So now when I take the same thing to a plant where my PLC code runs, there is a huge set of PLC code. Today we have a lot of programs running on those controllers. Now let's say there is a plant which wants to expand, which has all this code, and it wants to ensure that certain other parts of the plant also gets added. So what I do normally is I open this project which has all this PLC code and enhance by adding more modules. So now look at the same thing that I do in an IT world, right? Today I have huge test cases, test libraries, which will ensure that the regression is really done well for my source code. So if I add a new feature, I will run the regression and ensure that my past test cases pass. I have not touched that. So that's an IT part. Now, if I can bring the same thing for my control logic code within my factory, that would be a very nice example to see that you've actually brought in both worlds together. This kind of test cases for my control logic is not very prevalent, but maybe we should do that.
Fantastic. Thank you so much for that. I'll just take a step back, Shelly, and when we're talking about being able to adopt edge computing in our organization, specifically in India over here, I just wanted to check. We know the fresh talent and younger generations are adopting this new age tech in a big way. But could you comment on the requirement to either reskill or upskill existing technical talent when it comes to something like edge computing in an organization, and what that might require?
Yeah, sure. So again, when we saw that edge was not a technology, it's a philosophy. Yeah. And when it's a philosophy, a lot of creativity comes in. The way you strategize, the way you architect the whole thing comes in. Okay, having said that, so that's the important aspect, because if you get that wrong, then none of the technologies would actually solve the problem, right? So that's one thing to keep in mind. However, there are a lot of use cases which are edge specific, and the technologies would rightly be applied there. one of them I would say is the AR/VR technology that we have. Right. The augmented reality or virtual reality, right? So imagine in a plant, there is a logistic guy, okay, and he's looking for certain packets or certain inventory, which he or she is not able to find now. And how nice it would be if I can just wear a glass, augmented reality glass, and just key in saying this is what I'm looking at, and it shows in an arrow mark that through the plant you go there and you find it there. So this can be made possible using AR/VR technology. One is, the inventory itself should have some kind of identifying, like an RFID tag or something. And then once that tag is available, I can have a local edge running, which will keep track of where it is. And this AR/VR application that I have interacts with this server and finds out where it is and shows the path. So that's so AR/VR definitely helps. And another important one, maybe also, is that AI/ML technology is very active now. Everybody wants to do it, and the benefits that we get out of it. That has to be done, but when it comes to edge, there's something called ML ops, right? Machine learning operations. ML ops becomes very important because let's say I have deployed one of my models in the edge, and that guy is continuously running and giving me inferences or results. Maybe it's classifying some images. Now, over a period of time, what happens is let's say the climatic condition changes, or things in the factory has changed a little bit. And what happens, the model that I deployed becomes stale. Now it's not able to do the prediction as accurately as possible. Right. Okay. In that case, what happens is this ML ops comes in. That's where it comes. So it should ensure that the reference point is set to how accurate the model is. When the moment it goes down, it's called, there are possibilities like data drift and so on, which causes this. I should be able to get that trigger and retrain the model. So I would say ML ops also is an important technology that people can look at. So what I'm hearing is it's less about, it's less about upskilling, to your point, in the space of edge computing, because again, it is a philosophy. It's something that you end up picking up with your additional experience and so on and so forth. But what really helps is then kind of combining existing technologies like an ML ops or like an AR/VR to be able to leverage edge computing in the best possible way. Correct. Apply it in the right manner. Absolutely. Yeah, that's it. Fantastic. Okay, great. So just one more question. We spoke about startups in this space, and we definitely spoke about the kind of work that they're doing specifically in India, and especially with that as an all-time high. I just wanted to know if you could share some thoughts on to our audience on how India GCOEs can tackle this in terms of internally developing these kind of resources, or actually outsourcing edge computing to these startups, or kind of leveraging them to be able to integrate it into our system. Okay. Sure, we can do that, and we at Siemens also are doing that part now. So as we saw that um, uh, the organizations like us, we have fantastic technology people. I mean, there's no second thought about it, and that's where a lot of the whole world looks towards us. What I would say could be one of the improvements that needs to come in from my experience. It might be applicable to some people, maybe not to some people. Is we need to see, we need to understand, especially when it comes to edge, right? We are saying it's a philosophy and not a technology. So we need to understand what the customer pain points are. Okay, we need to really pay attention to that, understand what the customer pain points are. Probably taking one step back, the organization needs to create such positions where the people work on only interacting probably with the customers, visit the customers, identify what the customer pain points are, which up to an extent people are doing. But in this case, to generate edge revenue, right? Edge is a huge market. It's by 2025, I think it's going to double from what we have. So it's going to generate. So I mean, it makes sense for us to identify people who can understand these customer pain points and then get it back to the organizations, where then we can sit together, work, ideate, brainstorm, and then find out where it fits. And then our technology guys will take up. So that's one thing which we can do. So the challenge is also that many product managers that we have normally interact with the other product managers, who in turn interact with the customers, and that obviously limits my vision towards the possible solutions. So I would say maybe we need to concentrate there, and it's a little long term, but we'll get fruits from there.
So when you say concentrate there, you mean essentially reduce the number of layers or number of kind of
between customers,
the gap between an architect such as yourself versus the actual customers at the end of the day.
Correct.
Absolutely, I hear you. Thank you so much, Shelly. So I think the one last question I have that I would like to leave the audience with, and then we can maybe close. In the interim, we do have a lot of folks who have requested for some time to go over your presentation, and then they might come back with more questions. Sure. So to all of you who've said that, what we might do is, feel free to drop us questions offline as well. We will send them to Shelly, but we, try our best to convey them and get back to you whenever he has the time, if that's all right. And the last question, Shelly, is just, if you could share 3 key takeaways or pieces of advice for any India team that's about to embark on their journey with edge computing. They could be anything basis your experience, but what would those 3 things be?
Sure. So one of them would be probably what we just spoke. I would say try to understand the customer, where they come from, and then we know what we want to do. Another one could be, like we said, it's edge itself is a philosophy, right? So and how our philosophy is born, they're born out of questions, right? When there are a lot of questions, I get philosophies. So what is very important is the products that we have as organizations. In them, question whether the data that is sitting in this product is in the right place. Is it in a decentralized place? Is it in a centralized place like a cloud? So if you question where is the data, is it in the right place? And when I'm churning out on that data, can it be a little faster to the customer? Okay, if I look at that, so what that means is ask the right questions towards your data. So that's the second one I would say. And the third one is the edge market itself. The biggest share of that goes to the manufacturing industry, and then the energy industry, and then so on. So I would say there is a lot of potential in the edge solutions towards manufacturing factory. So I would say people could concentrate on that part. So that would be my 3 takeaways.
Yes. Absolutely. Thank you. So again, one more time, I'm just going to summarize before we even get to the 3 points. First and foremost, the fact that edge is a data network philosophy. It's not a technology in itself. So it's a lot about effectively strategizing and leveraging those existing technologies in a creative manner to be able to get to your outcome. And the 3 things you did you did share with us were to first and foremost understand the customer and where they come from. And then that kind of helps you identify what you want to do with edge. The second piece was asking the right questions towards your data, especially whether the data is sitting in the right place when it comes to the product. And can it be churned faster to the customer? And then lastly, you spoke about the fact that it's really upcoming as a market. And right now, manufacturing is the biggest kind of most popular industry at the moment when it comes to edge. Right. So I think that's pretty much it, and that's all we have time for. I do see a lot of pings. I'm just gonna. Okay, sorry. One more question. Why do we need to use? I know we still have 9 minutes of your time, so I will leverage them. Why do we need to use ML ops? How does it differ from basic ML? Does ML operations is that specific to Edge philosophy, or can we not directly deploy AI ML models under Edge philosophy?
Yeah. So I would repeat a little bit of what I spoke earlier. It is okay. ML ops is not specific to Edge. That's clear. That's the right thing that whoever has pointed out. But then the significance of ML ops is very high when it comes to Edge. So why I'm saying this? See, we also spoke about one point that what is the challenge for us when we are developing software for Edge, right? One of them was that a lot of software sits. Pieces of software sit on the edge, and for me it is difficult to troubleshoot because I am not very connected to all those sensors or the IPCs which are deployed. Now similarly, when I have my ML model sitting there, again the access to that is a challenge, right? It's not on a cloud where I can easily access. So once that is, so let's imagine it's a little disconnected. Okay, now there is a model which is continuously predicting something for the customer, which is very important for the customer. Okay, and the model itself is not being monitored. Okay. So it's possible. It's not just possible; it happens all the while that over a period of time, this model becomes stale. So once it becomes stale, the accuracy dips down. So there would be a point where the customer is getting predictions which are not that correct, and that's really not good, right? So what do you do in that case is that you bring in ML ops, where I'm continuously monitoring the accuracy of the model, or if that is possible. Sometimes it's not possible because I don't know what is the right result which it's predicting. So what I do is the data that is being fed into this model becomes a little technical, but yeah, the data that is being fed here is what initially I would have used a set of data to train my model, which is being deployed. Okay, now the data that is coming in, slowly the distribution of this data is going away from what I use for training. So I can actually monitor those points of the data and say that there is a data drift is one possibility. So once that happens, I can say, okay, inform the customer the model is not as good as anymore. All this happens using ML ops. So I can say it's not as good. Either you retrain the model with the existing data or probably remodel the whole thing. So how can I achieve this overall is using ML ops.
Got it. And the overall outcome is it definitely helps with troubleshooting, irrespective of the couple of examples that you mentioned. That's the overarching aim.
Correct.
Got it. Absolutely. Thank you so much. I think that is all we have time for today. Thank you so much for joining us, Shelly. It's been an absolute pleasure. For everyone listening in, I hope the session was insightful. I see a lot of pings asking for the deck, so we'll definitely get back to you on that. And if you have any additional questions, of course, please do send them to us via email. We'll do our best to try and take them up. Thank you so much, everyone. Thank you, Shelly, one more time. Take care and stay safe.
Thank you. Bye.
Bye.